So now that we've talked about various operators in Project Reactor's Flux and Mono, but primarily the Flux, let's go ahead and take a look at the implementation of the AsyncTaskBarrier framework. If you recall, this is what we're using in all the test programs to wait for asynchronous computations to finish in the background. It's got a very simple API. There's basically a way to register and unregister tasks and run the task. So here's kind of how you use it. As we've seen, you register these various tasks to run, and then you run the AsyncTaskBarrier, usually blocking until it's finished, and then we see how things work. So we're going to take a look at some examples from the test to make sure that we understand how this works in practice. So the AsyncTaskBarrier API contains these methods that register, unregister, and then run tasks. The tasks either run asynchronously if they've got things like subscribe on operations or their parallel fluxes, or they can also run synchronously. This works for that as well, although it's not as important for synchronous tasks as asynchronous tasks because they will block while they're running, and so you don't have to worry about the main thread falling off the end. Here's the methods that are used to register and unregister suppliers to methods that return monos to void. So that's really the only constraint. You have to return a mono to void. That's so that, as we'll see shortly, that's how the AsyncTaskBarrier knows that things are finished. These registered suppliers are stored in a list of suppliers to monos to voids. Nothing really particularly interesting about that. And then here's the method that actually runs. And this run task method doesn't block. And therefore, if you need it to wait, which you probably should, because we don't want the main program to exit before all the computations are done in the background running asynchronously, then you need to call the block method to block until everything's finished. So we're going to take a look at how to apply this in practice, but what we're really going to focus on are the test programs that illustrate how to test the way this program or this framework behaves. And this will also give you a chance to learn a little bit more about writing tests for Java programs using the JUnit test apparatus. So here we are in the EX6 project in my live lessons GitHub repository in the reactive Flux folder. And here's the test program we're going to look at. So this is a test program that will run a bunch of unit tests for the AsyncTaskBarrier class. As you can see here a little bit later when we get down further in this program, when we actually run it, it's got annotations that are JUnit annotations. And this is basically an instruction to the JUnit environment that this is an entry point that's meant to be run as a test. So as you can see here, this test function called test exceptions, not a very exciting name, but it's what it's doing, goes ahead and creates a bunch of local variables. And those local variables are all suppliers to monos to voids, and they can hold method references to the various methods under test. So let's go take a look at those methods under test, because they're really the interesting part of this. So here's one called synchThrowException. And what this is going to do, you can see it has a denominator of 0, which should be a red flag. And it's going to emit the numerator, which is the value 10. It's going to display some results so we can log things and see what's happening. And then it divides by 0. Now, you can see the compiler is yelling at us. The idea is saying, don't do this, but we want it to actually blow up. So we're going to leave it the way it is. So this was going to blow up. And this is a synchronous exception because this call runs synchronously. There's no asynchrony going on here. Here is an asynchronous version of this. And what we do here is we're going to emit the numerator, and then we're going to schedule the computation to run in a single thread. All that matters here is it's not running in the calling thread, so it's running asynchronously. And then in the background, we're going to divide by 0. So that will also throw an exception. So that's showing how we can throw exceptions asynchronously, whereas this is showing how we're throwing exceptions for synchronous method calls. Down here, we're going to show off some really funky features of Project Reactor and its error handling methods, error handling operators. And this is kind of weird, so let's talk about it. This is going to show how we can use onErrorResume without using onErrorStop. So we'll see how that behaves. So what's going to happen, as before, we're going to emit the numerator, and then we're going to divide by 0. Now, that's going to trigger the arithmetic exception, as it should. And we're going to use the onErrorResume method. However, and this is completely bizarre, there's a call to onErrorContinue in the AsyncTaskBarrier framework implementation itself. And it's there so that if errors occur, we don't necessarily stop the processing of all the other tasks. So there's a reason for having onErrorContinue. However, it's a bit non-intuitive. If you don't put an onErrorStop here, then this onErrorResume will not get run, which is bizarre, but we'll come back to that. Here is onErrorResume 2, and this shows what happens when we have onErrorResume in conjunction with onErrorStop. So same basic idea. We're going to divide by 0. We're going to call onErrorResume. We'd like to think that that's actually going to have some behavior, but it will in this case. This will not have any impact for this one because we didn't call onErrorStop. But here we call onErrorResume followed by onErrorStop. And this ensures that the onErrorResume method up here actually runs because it overrides the default behavior of onErrorContinue. If you think this is incredibly complicated, you would be right. It's very confusing and takes a while to get your head around it, but this is the way you have to deal with this. And it's what you might call a feature interaction issue. So they added some features that had certain semantics that then broke some stuff or made things complicated or difficult to do. So they had to have another method, onErrorStop, to override that behavior. I should hasten to point out that RxJava does not have this complexity, although it doesn't have this feature either in quite the same way. Here's a synchronous no throw. This doesn't throw an exception, so it'll complete successfully. It'll just multiply two things together. And down here, we have an asynchronous no throw, which also does not throw an exception, and it does the multiplication in a background thread. OK, so those are all the different methods under test. You can see we put them all into local variables so that we can unregister them properly. We then register all of these local variables, and we're going to directly register this method for various reasons. We register these local variables for all the other ones, so we can unregister them. We then go ahead and run all the tasks, so that will start everything running in the background, both synchronously and asynchronously. We then block the calling thread, and when things finish, only 3 of these tests should complete successfully. So we want to make sure that the test count corresponds to the number of these test methods that actually finished correctly and didn't throw exceptions. And so test count should be 3. So we use a JUnit assertion called assert equals, which checks to see whether things completed with the given amount. So then we print out what we got, which should work if the implementation is correct. By the way, the purpose of using unit tests like this is to ensure that any changes we might make to the AsyncTaskBarrier don't break its semantics. So that's why we write unit tests. Very good idea from the point of view of test-driven development. Then we come in here and we remove all of these different methods that we stored in local variables. That'll take them out, and we assert that they were removed, which they will be. And then we rerun the test again, and there should only be one test left because we removed all the other ones, and that should complete successfully. So that's what this does. Let's go ahead and run the program. AsyncTaskBarrier test. So that should compile and run it. And assuming that things are going our way, we'll get these results. So you can see that we got some exceptions. We're dividing by 0 synchronously. We're dividing by 0 asynchronously. And we're having the onErrorResume, which is actually called for that case because we use the onErrorStop, so that shows up. You'll notice that we didn't get a call from onErrorResume 1 because we didn't have onErrorStop there. And indeed, 3 tests completed successfully. We removed everything except the async no throw, ran the test again. We got 1 test. So that means that the program works, which is good. It means we haven't broken anything in the AsyncTaskBarrier. Very good habit to get into is to write unit tests when you're building your programs, because that gives you greater confidence, not guarantees, but greater confidence that your system is working correctly.